So let's go to the gear theory then. Again, I'm just reminding you again, please click this link whenever you have access. So what we have here, we have to transform the rotary motion between two shafts, okay? So in this case, the first option of transforming the rotary motion between these two shafts is using like friction drives. It's kind of, we are going here to develop how we come to use gears, for example. So imagine, just imagine, this is, you have a pinion pitch circle and you have a gear pitch circle. This is the imaginary circle. This is the imaginary circle for both pinion and gear. Imagine that they are tangent to each other at this point, and imagine that they are real cylinders. Okay, so if the first cylinder rotates in this direction and the second cylinder is going to rotate in this direction, and they rotate because of the friction between them at this point, okay? The second option is that if we think of adding like a belt, if we rotate a belt, we have here, in this case, we have two circuits. One is the pitch circle, and the second one is the base circle, which is this base circle, okay? If we rotate, just imagine you rotate a belt around the base circle of the pinion, and then extend the belt, and then rotate the belt around the base circle of the gear. So if you rotate the pinion in this direction, so the gear is going to rotate in this direction. Here in this case, the second case, you can transform more torque compared to the first case. And then mathematically, if you think of this triangle here and this triangle here and use some similarity between them, you will get to know that the ratio, the speed ratio here between these two cylinders is the same as the speed ratio between these two cylinders, okay? Because we've just reduced the diameter here with a specific amount, and we've reduced the diameter here with the same amount. So the ratio between the diameters of the two base circles here is the same ratio of the diameters of the two pitch circles. So we can achieve the same velocity ratio using these two, but the thing is that with this option, you can achieve more torque. Okay. The third option that we're going to talk about today is that we can transform the rotary motion, the motion and the torque and the power between two shafts using gears. Just they said, imagine that you've cut the belt, and then you've just formed the belt in such a way that you have involute profile. So you have involute profile DE, which is this one. And as I said, the involute profile starts at the base circle. So this is the base circle of the pinion. And then you have another profile, which is this profile here, GF, that starts from the base circle of the gear. So this forms part of the tooth. So because you can just carry on and then start like adding more teeth, etc. for both. And then you eventually form the gears. So the idea is like this. Okay. So the gear drive, so the teeth generated here from involute curves. So they become what's called a gear set. Okay. So we have pinion, and it is the smaller gear, and it is denoted by lowercase. Okay. Lowercase means that if the radius of the radius of the pitch circle is going to be small r, for example, and then the wheel is the larger gear, and it's denoted by capital letters. So we're going to, maybe we're using different notations here, but this is what we're going to do in the future. For as pinion, we're going to denote pinion with like smaller or lowercase letters, and denote wheels with uppercase letters. So if you look at the left-hand side here, the gear geometry, you have this is the pinion, okay, and this is the gear, and then the distance between these two centers is called the center distance, okay? And these two circles are this circle and this circle are two imaginary circles, and these two are called, as I said, pitch circle. There are lots of definitions here. You need to actually go through them one by one and try to memorize them. It's not because of exam or anything. It's just for you to understand everything about gears. For example, we call this above the pitch circle here, we call this part the face. We call this part flank. Okay. You have here addendum circle, which is touching the tips. We have the circle that is touching the bottoms, like the addendum circle. Then we have fillet here at the fillet radius at the root of the tooth. Then we have face width, which is the width in this direction, distance between here to here. We have circular pitch, which is if you pick one point on this teeth and then the corresponding point on the next teeth, and then the distance, the circular distance here between them on the pitch circle, it's called circular pitch, right? Then the radial distance above the pitch circle to the tip here, this distance here called addendum. So we have addendum circle, this is one thing, and we have a radial distance called addendum. So it's the distance between the pitch circle to the addendum circle. And then the distance between the pitch circle to the dedendum circle, this radial distance is called dedendum. The distance, let me just change color. So the distance between this point here to this point here is called tooth thickness. And this is a circular distance, and it's measured on the pitch circle, okay? This distance from, same from here to here, okay? From here to here, this void or this gap here, it's the width of space. So you have to just go through this and then try to understand the names. Here, for example, you have bottom land at the end, here you have top land, etc. And as I said, also, we are going to denote the pinion with smaller letters, and we are going to denote gears or wheel with larger or uppercase letters. So for example, here, the pitch circle is called the reference circle. So capital D here, small d here. The angular velocity, small omega here for pinion, large case omega for wheel. The number of teeth for pinion is T, small t. Number of teeth for wheel is capital T. Base circle radius R sub B, small r sub B, and a capital R sub B for wheel. Addendum circle radius, small r sub A for pinion, capital R sub A for a wheel. The addendum circle radius, small r sub D for the pinion, capital R sub D for the gear. So you just need to revise this slide again to try to understand the notations here that we're going to use. So the fundamental law of gearings, so we have what's called the velocity ratio, as I said earlier. So the velocity ratio is the ratio between the velocity of, or the angular velocity of gears in a gear set. And in order for this to remain constant, we have to use involute profile, right, for the tooth of the gear. So this velocity ratio is the ratio between the angular velocity of the gear or the wheel and the pinion, the diameter of the pinion and the diameter of the gear, the number of teeth of the pinion and the number of teeth of the gear, okay? We'll understand this plus or minus in a minute. What you see on the screen here is internal gears. You see here that this gear and this gear, they rotate in the same direction. So if you want two gears to rotate in the same direction, you should use internal gears, okay? So the plus minus sign here actually depends on either you have two external gears or two internal gears. So what you see on the screen is two internal gears. What you have seen previously is two external gears, okay? So if you have two external gears, so the direction of rotation is reversed, okay? So for example, if this is the pinion and this is the wheel. So if this rotates in the clockwise direction, this rotates in the counterclockwise direction. So the direction of motion here is reversed. That's why in this case, we should use negative with this velocity ratio. And then because in the case of internal gears, they rotate in the same direction. So we use the positive sign. Obviously, in the end, it doesn't matter because we use the absolute value of VR. But it's for you to understand that internal gears, they rotate in the same direction. External gears, they rotate in opposite directions, okay? So we have another ratio called torque ratio or mechanical advantage, T sub R. It is the reciprocal of VR. It is 1 over VR. So same equation, but the reciprocal of that one, okay? So TR is equal to 1 over VR, and it is small omega over capital omega, capital D over small d, capital T over small t. Okay. Eventually, what we are going to do, we are going to use what's called the gear ratio. So the gear ratio is G sub R. So what we can do, we just calculate the TR or the torque ratio. We calculate the velocity ratio, and then we choose whichever is greater than 1. So the gear ratio is the magnitude of either the velocity ratio on the previous page or the torque ratio on this page, and whichever is greater than 1 is used as the gear ratio. It depends actually, either we are increasing the speed or decreasing the speed, or either we are reducing the speed. The main aim of the gear set is to reduce the speed or to increase the speed, okay? So it depends on this, and eventually we have to have GR is greater than or equal to 1. Okay, so we have here also what's called the module. So each gear has module or has diametral pitch. What's the difference between these two? The definition of the module is that the module, small m, is equal to the ratio of the diameter to the number of teeth. So the ratio of the diameter over the number of teeth for the wheel, or the diameter of the pinion over the number of teeth of the pinion, and it is in millimeters, right? So if you look at the left-hand side here, you see, for example, if the module is 0.25, you see the size of the gear. It's very, very small. 0.3 is larger. 0.4 is a little bit larger, etc. So you keep going, and you see here, this is the size of the gear if you use a module of 8 millimeter. So the small module means smaller gears. So on the other hand, we have another definition called diametral pitch. So the diametral pitch is the reciprocal of the module. One more point about the module here. You see that we've just calculated the module based on either the wheel or the pinion. Why? Because the module is the same for for the same gear set, or for the pinion and the gear. So if you have a pinion and the gear, they are meshed together, they are engaged together, so they must have the same module, okay? Also, they must have the same diametral pitch, because the diametral pitch is nothing but 1 over m. But the thing is that because this is the diametral pitch is like a USA standard, but the module is British and European standard, so that's why here they use the millimeter. But here, the diametral pitch has to be represented in 1 per inch. So the diameter here should be inch, and the diameter here should be inch. And on the left-hand side and the right-hand side here, you see here the 4 diametral pitch, 5 diametral pitch, 6 diametral. It's going the other way around. So the more you increase the diametral pitch, the less it becomes.